Okay, so in this lesson we define the radian measurement angle as the arc length divided by the radius. We can sum this up using this formula. Theta is equal to arc length divided by the radius. Radius. All right. We can also rearrange that formula if we have anything else that we're looking for. So if we already have the angle theta and we have a radius but we don't have the arc length, we can rearrange this in order to find one of our unknowns. So for example, if we're looking for the arc length, we can rearrange by bringing my radius up here, so multiplying both sides by the radius, which would give me angle is equal to radius times theta. If we're looking for the radius, then all we got to do is say radius is equal to the arc length divided by the angle theta. Okay? Okay, so fistify. Oh.
May I go see about my glasses in my locker?
Sure.
Thank you.
Okay, so this formula, all we're doing is we're manipulating it by changing the variables around and bringing our unknown to one side. So isolating our unknown and then solving it. Okay? So let's look at an example where we need to do this. And so if you try to go in a little further in the questions, you may have run into this problem where you're like, okay, well, how do I solve and what am I solving for? So if you look at this problem in class example number 7, a pendulum 30 centimeters long swings through an arc of 45 centimeters. Through what angle does the pendulum swing? Answer in degrees and in radians to the nearest tenth. Okay, if you're thinking about a pendulum, this is like a pendulum, right? If you think about those old grandfather's clocks, they have the pendulum that swings like this, right? So you have an arc length that is formed at the bottom, and then if this were to go one complete rotation, then this length here would form your radius. And that's what we have. In these types of questions, it's really helpful to DAP. What does DAP mean?
Draw a picture.
Draw a picture. So I have my pendulum length that's 30 centimeters long, and it's swinging through an arc. That arc, I'm told, is 45 centimeters long. And what we're wondering is what angle does the pendulum swing? All right, so if my pendulum just swings back and forth, then it's going to swing from here all the way to here, in which case, where's the angle we're looking at?
Between those two lines.
Yeah, between those two lines. Good. This is the angle we're looking at, so that's where theta is. So through which angle does the pendulum swing? So we want our answer in degrees and in radians. So what's the formula that I'm looking at here?
Theta equals arc over radius.
Good. Theta is equal to my arc. And which one's the arc length?
45.
45. And so what I'm going to first do is just make a list, right? So we're kind of approaching this like the way we would approach a problem in physics. But my arc length is 45 centimeters. My radius is 30 centimeters. And theta is equal to arc length over my radius, like so. All right, so fist of 5 so far, 1 to 5. All right, good. So if I look at angle theta, my arc length is 45. My radius is 30. So my angle here is going to be 3 over 2. Now, what does this mean, 3 over 2? If we're talking about radians, it's 3 halves of what? Connor?
That's like, pi.
Yeah, good. So this angle, if it's radians, it's 3 halves of pi. All right. If we're talking about this angle in degrees, what do we need to do?
Multiply by 180 and divide by pi.
Good. So if I want to find my angle in degrees, so radians, 2 degrees, remember? Would be 180. We have to multiply by 180 over pi. All right, so this is just the conversion that we're showing here. So my angle in degrees is going to equal 3 halves pi times 180 over pi. All right, let's look at example number 8. So calculate the arc length to the nearest tenth of a meter of a sector of a circle with diameter 9.2 if the sector angle is 150 degrees. All right, the first thing I want you to do is draw a picture. So let's start by doing something like we did up here. We're looking for the arc length here. And so you can even start making your list as you draw your picture. I'm told that the angle is 150 degrees. And I have a diameter of 9.2. So if I have a diameter of 9.2, then what's my radius? Is that 4.6? Good. 4.6 meters. And I'm told that the sector angle is 150 degrees, so theta is 150 degrees. So how would I organize this formula if I'm solving for my arc length?
R times theta.
That's right.
A is equal to R times theta.
Good. So A is equal to R times theta. So A is equal to R times theta. If A is equal to R times theta, then if I were to just multiply 4.6 by 150, I'm gonna get a huge number, which won't really make sense. So what do you think I need to do here? Connor?
Convert theta to rads.
Yeah, so I need to convert my theta into radians. All right. So if I convert this into radians, then we're going the opposite way right now, right? So we're going from degrees to radians. So degrees to radians. We're going to multiply by pi over 180. So by 0.83333 pi, we're going to get my arc